Okay, little video about the NRG zone unit. This unit's been of interest to me for a long time. I have asked for sort of further conversations, more information on the unit and how it functions, and that's been pretty much hard to come by. Plus, just about every time we do a post about using hydraulic separation to satisfy the differential flow requirements when applying a boiler, the low temperature gas boiler, to a system with a mixture of radiators and underfloor, or even just a system with just underfloor heating on it. We discuss about the need for hydraulic separation. This is posted up as being a smarter and better option, and I've been suggesting that this isn't the case for a while. Finally, I just think it's about time that I actually had a really good deep look at this and show what it actually is and what it does and why it won't work in the scenarios where we're advocating the use of hydraulic separation. So basically this is the layout of the NRG zone and the core use of it. If you imagine us applying it in the scenarios that we're applying it in the forum, I'm not denying that it's got its place, it's got its uses, but it's being posted as an option on the posts that we're putting up about underfloor heating and low temperature gas boilers. And that's the point I want to point out that it won't work for. So let's apply it to that. So we would have our input from our condensing boiler here, maximum of 50 degrees centigrade. And we're talking about underfloor heating systems and radiators mixed. So for a low temperature design, 50 degrees in here, 30 degrees out of here. And we've got immediately access to port 1, and then port 2 and port 3. And at this point, we would get obviously flow going off down this way. And then if there was some return mixing going on, we would get mixed into these. So we would have differentiating temperatures across here. But anyway, the function is the flow comes in here. It can go down any one of these first flow tubes, so flow 1, flow 2, flow 3. And the returns coming back from the circuits are then drawn back into our boiler this side. You can have a boiler this side. This is actually the unique feature. If you're trying to mix a high temperature source, you've got some other options here, but that's not the scenario I'm discussing here. So what would this look like if we tried to look at it in a more familiar way? We could actually take this thing out and fold it out and fold it out and fold it out, and we would get the image of a standard low loss header that would look like this. And if you've followed me on YouTube, you'll have seen me do a video of this and explain that this is the incorrect way to pipe up a low loss header, and you would not do this if you were going to have underfloor on a heating system. So that's the thing unfolded. We've got our flow 1, flow 2, flow 3 with the priority off the top. Then we've got this high temperature return option in the center. Actually, I should have drawn 2 for that. So there's a little error there. There should be a second tapping off the back here for that one. Then we've got return 3, return 2, return 1, and we've got our low temperature returns coming out. So it's a pretty good demonstration of what we're actually looking at hydraulically. And this is the explanation of why it won't work in the scenarios where we're applying close coupled T's, mixing valves, etc. So basically we've got a gas boiler here for my demonstration. Now I've chosen a really big output here. 21 is a lot of power out of a gas boiler for a modern property. We've got 21 kilowatts, a delta T20, which gives us a flow out of 0.25 litres per second. And then I've put a 7 kilowatt underfloor heating system on here, which requires 0.24 litres per second. So basically our flow comes in the boiler and it disappears off down our underfloor heating system. And a tiny little bit, so that's 0.01 litres per second, will be left in the header to come off in this direction. Now the radiator circuit here, I've put 7 kilowatts, 2 radiator circuits requiring 0.083 litres per second on each circuit. Now these have no longer got any flow available from the boiler, so these are going to recycle their own returns here So there'll be no heating going on in this part of the system, and the return here from the underfloor heating circuit will be directed straight back to our boiler, and a tiny little bit of flow from this one will come to mix in there. So really, we've got to stop having this suggested as an option on these posts. Let's talk about where NRG is a good product and has good applications, and understand it for what it is and where it's got a purpose. And if we have that need and that use for it, let's buy it, let's use it for that. But let's not try and apply it where it's not a workable system.